Exercise set 1.4. Applications. Two-variable linear systems of equations. Standards of solutions. Define all variables. Explain the source of any newly introduced equation. Assess the correctness of the solution by performing two types of checks: a check of the math problem solution and a check for sensibility in the real world. Of the two checks, the latter is the more important. Be reminded that the most likely source of error in an application problem lies in the translation from the real-world problem to the math model problem, thus the importance of a sensibility check. Calculator usage is required. Exercise 1. A movie theater collects $5,022 from sales of 497 tickets. Adult tickets are $11 each, and student tickets are $8.50 each. How many adult and how many student tickets were sold? Okay, let's see. For defining variables, probably go with something such as let x equal the number of adult tickets sold and then y can be can use little ditto marks here, number of student tickets sold. Okay, now let's see here. What source of information could lead to some kind of equations here? Well, we have a total of 497 tickets sold. Okay, let's translate that into math. Total number of tickets is 497. Okay, the translation for total number of tickets would be the adult tickets plus the student tickets equals 497. Okay, there we have an equation. So I like to sort of make a note of that. It's an important stage of the problem. Call it equation 1. And now let's think about some other information we have here that belongs in the math model. Okay, this $5,022 of receipts, we could say that our information is that the total receipts is $5,022. Okay, now that total receipts comes from receipts from sales of adult tickets and receipts from sales of student tickets. Okay, let's translate that. For the adult ticket receipts, we would take the number of adult tickets and multiply it by the $11 per ticket price. So this would be 11.00 x adult receipts plus now student ticket receipts. Each student ticket, $8.50 times y of them would give us the receipts due to student ticket sales. So this total is equal to 5,022. Alright, there could be equation 2 in our math model. Let me make sure we have everything in the problem accounted for, which seems to be the case. And now what kind of math problem have we got? If we look at these equations 1 and 2 here, you notice two variables, linear in each. Okay, so observe. You don't have to write this down, but it's important when you're doing a problem to make a note of what kind of math problem have you gotten into here. So here we're going to say that we observe that equations 1 and 2 constitute a system of linear equations. Two variable. Alright, well, we're very proficient at this kind of problem mathematically. Let's see here. Maybe we choose to use a calculator as the numbers are maybe not so simple. Let's do that. And let's see, in the first equation, we could solve for y by subtracting x from both sides. y1 would equal 497 minus x. In the case of our second equation, solving for y by subtracting 11x from both sides, divide both sides then by 8.50, we could have y sub 2 equaling to quantity 5022 minus 11.00x divide by 8.50. Alright, at this point we're ready to go to the calculator. Here at the calculator, we can go to the y equals 2 edit screen. Our y1, we have here 497 minus x. For our y2, we have a parenthesis 5022 minus, okay, 11.00, don't need to put the two zeros there, times x, parenthesis, divide by 8.5. Now, let's see, which coordinate system should we look at? In this case, since it's a real problem, we can consider what are the possible values that x could take on. X is the number of adult tickets sold. Well, the total number of tickets was 497. So the possible sensible range is between 0 and 497. We might set up the window to reflect that first. So go to the window, x min 0, x max, the largest sensible, possibly sensible x would be the 497. This is the case where all the tickets sold, or adult tickets actually. With that much in order, we can now go and just do a zoom fit, force the y-axis to show all the graph. Okay, looks like our system of linear equations has a single point solution there. Let's go get it. Second, calculate, intersect. Okay, that's our first curve, that y1. That's our second curve, that y2. For a guess, move that graph cursor over a little bit there, about there, enter. Okay, we have these numbers here for x and y. Alright, let's start to record what we have here. So here in our solution, we have this x equaling 319 and y equaling 178. Now, this is a real question, so we want to translate this back into the real world. What does this mean? Okay, x, that was the number of adult tickets sold. So we apparently believe that there were 319 adult tickets sold and 178 student tickets sold. Now this would be the major conclusion of the problem. Alright, now let's start checking this over. As a check, the instructions have us take on two types of checks. One is a math check of the math problem. Okay, so we can start with that one first of all. Okay, let's see. What we can do is use the original equations to make sure they are being satisfied. Remember, the only source of a math error in this problem would be the rewriting of the equations here where we solved for y1 and y2. So going back to the original, let's take the left-hand side of equation 1, that's x plus y, see what the calculator gets there. And the second equation, its left-hand side was 11.00x plus 8.50y. Let's see if we can't get the original right-hand side there. So now we can go to the calculator for a moment. Alright, at the calculator we can second quit, go back to the home screen, and let's try out this first one. X plus y. Enter. 497. Alright, that's just as in the original first equation. The second equation's check. 11.00 x plus 8.5 y. Enter. 5022. Okay, that's a check as well. So back here we have found this to be 497. That looks good. This came out to be 5022, just as the original equation, right hand side. That looks good. Now, this is a application problem, and the math error is not the likely source of error. It is actually the translation of the real problem into a math model that represents the big source of error. So now let's go ahead and check for a sensibility of this solution here. Now, one thing is kind of nice to see. The 319 and the 178, those two numbers, they add to 497. That's kind of the same as a math check in a sense there. But otherwise, what else could we do here to make this solution feel right? Well, sometimes if you consider simple cases that don't require very much complicated calculation and compare this result to simple cases, you can start to build some confidence. Here's what I have in mind. For instance, what if all the tickets sold were adult tickets? Okay, so if all 497 tickets were adult tickets, the receipts would equal, now here's one that's not hard to do. You just would have your 497 times 11, and we'll work that on the calculator in just a moment. The other, a simple case, also an extreme case, how about if all 497 tickets were student tickets? The receipts in that case would equal, now we'd have 497 times 8.5, and we can get a number there in the calculator. Okay, so 497 times 11, an all-adult case. Receipts then would be this 5467. Okay. In the all-student ticket sales case, that would be, and you can do this sometimes, if you've seen this, second entry. Anytime you're doing a sort of repetitive calculation where you just need to change one number, you can use second entry, come back with something previously entered, and then we can just go back and overwrite the 11 with an 8.5. And enter. Okay, Let's put these numbers down on our paper. So we've found that in the all adult ticket sale case, we have 5467. In the all student ticket sale case, we'd have 4,224.5. Now, with this information, you can think about the actual receipts themselves. The actual receipts of 5022, and now consider what this more closely resembles. Is it a closer resemblance to an all adult ticket sale, or is it a closer resemblance to an all student ticket sale? Well, at 5,022, it's about 450 or so, 440 away from this number, but it's about 760 or so away from this number here, meaning this 5,022 more closely resembles the all adult ticket sales case. So the actual receipts of 5,022 more closely resembles the all adult ticket sale scenario. And what this means to us is that if this is the case, we expect our answer to have more adult tickets than student tickets. Does it? Yes, we had 319 adult tickets, 178 student tickets. This is the kind of thing we like to see to make us feel confident about the way this solution is running. Okay, so let's finish up our sentence here. We have that thus we expect more adult tickets than student tickets. And with our answer, this is indeed the case. Okay, so that makes this feel a little bit sensible as far as the way the numbers have panned out. And that would finish up the complete check of the assessment of correctness of this solution. Exercise 3. Anne invests $25,000. She put part of it in a commodities-based mutual fund that paid 6.5% per annum, and the remainder in a stocks-based mutual fund that paid 8.2% per annum. After 1 year, the total interest earned was $1,916.64. How much did Anna invest in each fund? Round to the nearest cent. Okay, let's think about how we want to define our variables. Well, in this case, it's probably pretty clear choice to something such as this. Let's let x equal the amount invested in the commodities based. Let's just call it commodities for short here, and that'll be in dollars. And then y could equal the amount invested in stocks for short. It's clear what that means from this question. Okay, now let's see what sort of information have we got here that could lead to equations of any sort. Right in the beginning sentence, Anne invests $25,000. Okay, so in other words, the total investment is $25,000, this would lead to a translation of being x plus y equals 25,000. Okay, got an equation there. I'll call this equation 1. Alright, let's see. Let's look around at the other information here. This sentence here looks pretty important. After 1 year, okay, total interest earned was $1,916.64. Okay. Total interest earned is 1,916.64. Okay, well, this total interest comes from two sources: interest from the commodities fund plus interest from the stock fund. Okay, so let's translate what that would be. The interest from the commodities fund will be the amount invested times the rate here of 6.5% per annum. Okay, now since we have percents, we can put them as 0.065 x plus, okay, interest from those stock funds. Their interest rate was 8.2% per annum, so in other words 0.082 y, and that equals 1916.64. Alright, there's an equation. So I'll make a note of this, call it equation 2. Now that looks like that accounts for all of the information in the question. There's nothing else to say. So now it's time to look at the kind of math model that we've developed here. Well, this problem here would be a system of equations, and each equation is linear, two variables. Okay, so you don't have to write this down, but it's nice to get in the habit of looking at the kind of math model you have and saying something at least to yourself. So observe that the math model is a system of linear equations. Two variable. Okay, well, let's go ahead and go with a calculator solution. The numbers look a little messy. So let's see, we take equation 1 for calculator usages. Remember, we would solve for y, so in this case it's pretty easy, just subtract x from both sides. We could have a y1 equaling 25,000 minus x. In the second equation's case, we could, let's see, I was thinking about multiplying to clear these decimals, but I suppose not. Let's just simply subtract the 0.065x from both sides, and then divide both sides by the 0.082. We'd have y sub 2 equaling, in parentheses, 1916.64 minusing 0.065x divided by 0.082. And it's time to go to the calculator. At the calculator, let's go to the y equals 2 edit screen, and y1, 25,000 minus x. For y2, parenthesis, 1916.64 minus 0.065 x parenthesis divided by 0.082. Okay, now what about a coordinate system? Since this is a real problem, we could consider what are the possible values x could take on here. X is the amount invested in a commodities-based mutual fund. Since the total investment is $25,000, the possible x's range from 0 to 25,000. So we might as well set up a window that has that to begin our graph. So here at the window, x min 0, x max 25,000. And now don't worry about trying to think about the corresponding y's. Just go ahead and have the calculator take care of the rest for us with a zoom fit. Okay, looks like we have a single point solution. It is rather up in the upper left-hand corner of this graph. I think now that I see this, I would like to maybe get a closer look at where all the action is. One way to do it would be to do a zoom box, one of my favorites. In zoom box, you simply move the cursor around, deciding on where you want one corner of your box to be. Okay, I'll pick this to be my lower left corner, enter, and then I'll go way over to the left, and then up. Okay, and then enter. Okay, well, sometimes I might even do a zoom box again, but right now I think I have a pretty good idea of being able to see things clearly here. Time to do a calculation of the intersection. So for this, second, calculate, intersect. Okay, first curve, yes. Is that our second curve? Yes, it is. As far as a guess goes, okay, move the graph cursor over to about there, and enter. Okay, so we have this here. Let's round these to the nearest cent and start to record our information on our paper. Alright, looking at that calculator display, we have that x there. Okay, let's maybe at the same time, let's translate this into the real world. So we should make a sentence here, and it would be that Anne invested to the nearest penny. This would be 7,844.71 in the commodities based mutual fund, and invested, quote, ditto marks here, reading that y value there and rounding it to the nearest cent, 17,155.29 in the stock based mutual fund. Well, this is our big conclusion of this question, so this will go in the prominent cloud. Alright, let's start checking this over now. 2 checks. 1, just a math check. And more importantly, sensibility. Okay. So here in the checking phase of this, let's check that math out. For this, we might do real well to go to the original equations and see if these x and y here really do meet the original equations. Remember, the source of error in the math part of this would be the algebraic rewrite for the y in each case. So that's what we need to take a first look at. Back to the original equations. Original equations. The left-hand side of original equation 1 was x plus y. Let's see what that is on the calculator. The original equation 2 was 0.065x plus 0.82y. The right-hand side, let's see what happens there. Alright, back to the calculator. So now we might do well to go and second quit, return to the home screen. And first of all, our x plus y. Enter. Okay, as in the first original equation, it's good. Now the more challenging second equation, its left-hand side, 0.065x plus 0.082y. Enter. 1916.64. Okay, same as the original second equation. Alright, looks like we have our math check in order. Go back to the paper. Okay, so we found the calculator came up with 25,000 here. That's the same as the original first equation. And then the calculator calculation, 1916.64, agrees there. Alright, so at least the math part looks pretty good. How about sensibility? Again, this was a real question, so the most likely source of error is the translation from the real world into the math model. So let's try to think about that for a minute. Well, one thing is the fact these two numbers do add to 25,000 is kind of a sensibility check in itself, so that much is the same as a math check in a way. It's something very simple to check, and you want it to be true, of course. Now, the other issue is more complicated. What could we do here without, reusing our second equation, which was kind of a complicated equation? Well, we could consider extreme cases that don't have very complicated equations going with them. For instance, what if Anne put all the money, all $25,000, in the commodities fund? Okay, so if all $25,000 was invested in commodities, roughly speaking, the interest would be, okay, we just have to do the 25,000 times the 6.5%. Get a number there on the calculator. The other extreme case, what if all 25,000 was invested in stocks? Okay. The interest would be 25,000 times the 8.2%. Okay, let's go see what these numbers are on the calculator. Okay, so 25,000 times 0.065 enter. Okay, 1625. The other case we could do by second entry and then just editing the decimal number here. It's 0.082, so a little over right there, and enter. Okay, let's put these numbers on our paper and think for a minute. Okay, so here we came up and had 1625 here. In this second case, it was 2050. Now, the actual interest, what was that? The actual interest, which was the 1,900. How does that compare to these two extreme cases? Okay, you know what? It's actually pretty close to this 20,050, just like $130 away from this one, whereas it's nearly $300 away from this one. So the actual interest much more closely resembles the all stocks investment. And since this is the case, we expect much more of Ann's investment to be put into the stock fund. Look back at our actual answer. Well, 7,800 or so in the commodities, 17,000 plus in the stocks. That is indeed the case. Okay, so this is starting to feel like a good answer based on this. Let's finish our statements here. So the actual interest much more closely resembles the all stock investment. This is indeed the case. Well, in other words, vast majority of investment is in stocks, and thus the solution seems sensible. Okay, so now the answer is, in a sense, intuitively feeling correct as well as satisfying the math problem that we developed. Looks good.